Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khaldi explaining finding an unknown coefficient by solving quadratic equations in complex number set. The first way to find this unknown coefficient is explained in the first box. We can see that if one of the roots of the quadratic equation called z1 is given and it is required to find an unknown coefficient in the equation, then simplify by substituting the root or the solution or the zero which is given into the equation. In the second box you have a note. This note is saying if given that the two roots of the equation are equal, then you can use this relation b squared minus 4ac equal to 0, which is the discriminant. So I can call it also delta, or I can call it the discriminant. That is discriminant. And this discriminant should be equal to 0. And that can help you to find the unknown coefficient. Let's start by the exercise, and the first exercise is talking about write true or false in the statement. Number 1, if the two roots are equal, and that means we are going to use this box in the equation, which makes the delta or the discriminant equal to 0. Then he wants you to tell that k equal to 9. Let's start by delta, which is b squared minus 4ac, and equal it by 0. Be sure that your equation is equal to 0. Then try to focus on a. A is equals to 1. So this is A. B is equals to negative 6i. So this is B. And don't forget the negative. And C is going to be this K. So C equals to K. Be sure that your equation is equal to 0 before you're going to do this. Now replace in the delta. Negative 6i instead of b squared, negative 4 times the a is 1 and c is k. That all should be equal to 0. If you square the negative under the root, that will make it positive. And the 6 will be 36 and the I squared will be negative 1. Then negative 4k equals to 0. I can move negative 4k to the other side, or you can move negative 36 if you would like to. So if you're going to move it, you can change the sign from negative to positive. And you can get negative 4k equals 36. Divide both sides by negative 4 here and there and cancel them. You can get k equals negative 9. And the answer he gave you, it was positive 9, which is not true. So it is false. In number 2, the equation again, I z squared minus bz plus 4i equal to 0 has 2 equal roots. So again, he is talking about equal roots. So we're going to use the delta again. Then the value of b equals to 4. So let's use the delta. And delta will be the discriminant equals b squared minus 4ac, and that all equals to 0. Go back to the equation and be sure the equation is equal to 0, and try to focus on a, which is I, which is the coefficient of z squared, b, which is negative b, which is the coefficient of z, and c is going to be the constant term, which is for I. We can have them all now in the formula. B squared will be negative b all squared, negative 4 times I times c, which is 4i. That all should be equal to 0 to make the equation with 2 equal roots. Negative, if you square the negative, will be positive because it is inside the bracket, and the b squared, it stays squared. Negative 4 times 4 is 16. And I times I is I square, and I square will be negative 1, and that will change the negative to be positive. That all equals to 0. I can move the 16 to the other side and change it from positive to be negative, and that will make it b square equals negative 16. Take a square root for both sides, and that will take away this square or cancel it. But in the other side, you should get positive or negative 4i. Our answer is 4 only, not with I or plus or minus. So that will make the whole statement false. In the third, if I is one of the roots, so the root is given. Because the root is given, so you are going to replace it by taking the value of z and try to replace it in the equation instead of z to get the unknown value. So here, let z equals this I. Now try to substitute it in the equation like this exactly. I all squared minus k times I from here equals 3. No need to equal this equation by 0 because we are not getting a and b and c. We are only checking if I is a root of it. So we need to prove that left side is equal to the right side. I square is negative 1 minus k, and then I times I is going to be I squared, and I squared will be later on negative. So negative by negative is positive 1, and that all will be equals to 3. I can move this negative to the other side, and that will change it to positive to be added to 3. So you can say that k equals 3 plus 1. So k equals 4, which is similar to the answer that he gave you. So it is true. Any question? 1. Choose the best alternative. You can see that he is giving you again the value of one of the roots. If negative I is one of the roots of the equation, ac squared minus z equals bi plus 3, and this a and b belongs to real, not complex number. So a and b can't be with I. They should be real. Then the difference between them will be equal by writing b minus a. Now we have the value of z is given, z1 is given, which is negative I. I will replace it in the equation, substitute it by writing a, then bracket negative I to the power of 2, then minus negative I, that all from the left side, and the right side including b I plus 3. We need to find the values for a and b. So we can evaluate this negative under the square to be positive, and the I under the square to be negative again. So the answer will be negative a. Negative by negative here with the next will make it positive. So it is positive I equals to bi, and that all plus 3. So don't move anything, just try to equal real with real and imaginary with imaginary. Real, which has no I, we can equal them together by taking real part equal to real part. So that means we have negative a equals to 3. Divide both sides by negative, you can get a equals negative 3, and this is the value of a. Now if you're going to equal imaginary with imaginary, you can equal I with bi, and that means imaginary part will be equals to imaginary part. You can have 1 equal to b, which is the coefficient of the I. Now I have b, I have a, I can go to the required, which is asking you to subtract b minus a from here. B is a 1, and there is a minus from the required, minus 3. That will make it 1 plus 3, which is 4. So the answer is the fourth one, the fourth alternative, which is here. Let's go to number 2, and we can see that we have this given. F I is a root of the equation z squared plus 1 plus I, with a z equals 2x plus yi, where x and y belongs to R, then x plus y equals. Let's have now the value of z, which is given, it's I. Then we are going to replace or substitute this z instead of it in the equation by having I squared plus bracket 1 plus I, close your bracket and open another bracket including I again, equals 2x plus yi to the right side. Now after simplifying the left side, you can have I squared, which is negative 1, and here you can multiply I here and there. That means you can get I plus I squared from here. That means I squared is negative 1 again. That all equal to 2x plus yi from the right side. After adding negative 1 and negative 1, you can get negative 2. So this negative 2 is real. I can equal it with real part. So here, real together will be equal to the real, which has no I. So real part will be equal to the real part from both sides. Negative 2 to the left and 2x to the right. By dividing to both sides, you can get x equals negative 1. And this is the value of x. Now I can equal imaginary with imaginary, like this, I with yi. By equal them, I can have the imaginary part from the right side equal to the imaginary part from the left side. So 1 to the left equals to y to the right. I get the value of y and x, and I can go back to the word then and try to add them. X plus y equals, x is negative 1 and y is positive 1, and these two will give you 0. So you can choose one of the alternatives, which is the second, which including 0. In the third, we can have this equation. F2 minus 3i is a root of the quadratic equation z squared plus 3iz plus c equal to 0. Then He wants you to find C. Also, you have one of the roots is given, so you can replace it again. So Z equals 2 minus 3I is a root. That means it's a solution. So always try to substitute it in the equation, which is including Z squared first. So 2 minus 3I will be squared plus 3I multiplied by the Z, which is 2 minus 3I, plus C equals to 0. Now try to expand this square, perfect, by using the rule, which is squaring the real to be 4, and then minus always, and square the imaginary part, which is 9, close it to be the real part, and then plus always between real and imaginary. Then you can write 2 multiplied by 2 times negative 3 times I. Don't forget to take this negative in a bracket at the end. I am done with expanding the perfect square. Now we are going to expand this bracket. 3I multiplied by the first and multiplied by the second to get plus 6I, and then positive times negative is negative. 3 times 3 is 9. I times I is I squared. That will make it negative 1, so that will change it to positive. Then plus C equals to 0. We need now to evaluate as possible and try to find the values of C. 4 minus 9 is going to be negative 5. Negative 5 plus 2 times 2 is 4 times negative 3 is negative 12 with I. And then plus 6I plus 9 plus C equals to 0. Let's add as possible the real part together and imaginary part together and try to find C. Real parts are which has no I, like negative 5, positive 9. Together we can subtract them, and that will give you 4. Then let's add the imaginary part together. Negative 4I and negative 12I and positive 6I, and that will give you negative 6I, and that all plus C equals to 0. I can leave C in the left side and move 4 and negative 6I to the other side, and that will change all signs from positive to negative or from negative to positive to get C equals negative 4 and positive 6I, which can be the third choice here. It is negative 4 plus 6I. It is the third one. That's it. Thank you very much for listening. Good luck.